Okay. Good evening, everybody. We hope you have enjoyed your EuroPython day so far. So, remember, no. Well, we've got a couple of minutes, so we'll just know. Okay, it's great. Tonight we have got the Google Code Jam. You should register on the EuroPython website if you want to join. And always remember, after the talk, you can vote for the talk on Guidebook, your mobile application, or on the website. So, now, let's welcome Daniel, who has come from the US, just to show us how hard it is to think about Python. Thank you.
Hi, can you hear me okay? Okay, so hi, I'm Danny, or Daniel. Danny is the informative version of my name. I know it's been a long day, and there's festivities that are going to be starting, so I'm going to try not to take up too much of your time. And I'm also going to try to follow in the footsteps of awesome people who have come before me, Armin, Martin, Paul. We'll see what I can do. So yeah, I'm in Italy, which is awesome for an American. It means I'm winning at something. So this is me. You can find me on GitHub or Twitter or pretty much any place. I'm known as PyDanny. I also work as a principal at a company called Cartwheel Web Development. I'm a principal there, and we do Python and Django consulting. Excuse me. I'm a little bit nervous here. Well, one of the things that I did this year is I published a book, or I co-wrote a book on Django. It's a best practices book. It's one of the 2 modern books about Django, which is awesome. And I co-wrote it with Audrey Roy, who's right here. She's my fiance, who I met at PyCon US 2010. And so PyCon is awesome. And I just want to point out something. This is my commits to the book, okay? Yeah, well, there's a lot. The book is over 300 pages. There's a lot to it. And people come up to me and they'll say stuff like, oh, you got something wrong. Especially the whole Apache environment variables thing. I'm sorry, we use Nginx a little bit too much. Or they say, hey, I really like this book. I really appreciate it. The thing is, though, is that often people will skip Audrey, who co-wrote it. And this is her commits. She did a lot of work. I mean, and actually, these stats aren't exactly accurate because I copy-pasted stuff from an earlier version, which wasn't on GitHub. And she also did the art and illustration in addition to code and writing and tons of stuff. So don't just come up to me and say, I really liked your book, or you got something wrong in the book. Come up to Audrey. Or maybe just say the nice things to her and say the other things to me. Yeah. OK, so on to the talk. This is what I want you to think of me. I do cartwheels. I've been doing them since I was a kid, and I've been doing one-handed cartwheels since I was a kid. And I get to travel the world while I'm doing cartwheels, or I find ways to afford being able to pay for it. And I do exciting things. I get to come to Florence, Italy, and eat amazing food and see that all the Italians are kind of heavy. And then I realize those are actually American tourists. So yeah, this is what I want you to think of me. I'm this cool guy. But that's what I'm really like inside. That's me. I think I was 12 or 13 in front of our Apple II, and I was teaching myself Apple Basic. And the thing is when I was that age, I got obsessed with coding, or writing Apple Basic, writing games, and all kinds of stuff like that. We've all been there, and that's how I still am today, to the chagrin of family and friends and loved ones, where I get distraction. Like they start talking about something, and I'm thinking about, okay, how do I do linked lists in Python, and make it actually perform well. So that's what this talk is about thinking hard in Python and what this means for me and maybe for you. So, and there's several parts of this. I'm going to talk about coding yourself into trouble, which we all get to do, some controversy, and I'm going to pick on some people, but I'm going to justify myself. Exceptions, and there's going to be some pretty evil stuff here, and avoiding technical debt. All right, so let's dig in. The first one is coding yourself into trouble, which I certainly have done quite a bit. And this is where I go into super. So Raymond Hedinger is a hero of mine. He's this amazing speaker, an amazing developer. He's contributed great stuff to Python core. And he gives this talk about how super is super. And it's so elegant, especially once you get into Python 3. And it's really obvious. This is using pretty much a copy of his code, which I made sure was running Python 3. This is really obvious if you've been doing Python for a while. If you haven't been doing Python, basically, I have, donut is inheriting from circle, and then inside the init, I'm calling the initialization function of circle to get the behavior there. So Python 3 makes this trivial to do. Python 2 is a bit harder, but Python in general makes it really easy. We should all use inheritance and super. Well, see, here's the problem. In the real world, that's not always the case. So the contention I'm going to make right now is that super can get us into trouble. And I'm going to pick on something now, and that's Django. And I feel like I'm qualified to pick on it because I wrote a book on it. So, in fact, I'm going to pick on class-based generic views. This is actually a contentious subject in the world of Django. There's this whole functional-based views versus class-based views discussion. And I'm actually in the class-based views preferring camp of things. I'd like to use them. I'm just going to say that right now. And the reason why is because they give us stuff like these great buzzwords here, which you can use to impress your friends and family. You just start throwing them out. What's great is when you do it with junior developers or developers who know more than you do, and you're trying to sound like you really know what you're talking about. So this is what class-based views, especially the generic views, get you. Here's the thing, though. Who here does Django, real quick? OK. Look at the screen. Don't look down at your laptop. I'll get really upset. I don't know this. I do not know the ancestor chain. I wrote a book with chapters on class-based views, and I've written a ton of blog posts. I don't know this. And I can't say any of you do, because this is it. This is the ancestor chain for the update view in Django. This is a lot of stuff, and it's not a direct line of inheritance. We're talking, diamonds and rubies and all kinds of other crazy patterns. And this is where you get into trouble. So for example, whoops, I think I went back. Yeah, I did. OK, so here, for example, in the form method of this, which is one of the methods for the update view, I don't know which form valid method I'm calling. I'm not sure. If I'm inheriting from 9 other classes, what exactly am I calling? Well, I can kind of guess that I'm safe, right? I'm not safe when I see this. And this is code I wrote. I'm inheriting from 5 other classes, like some mix-ins and stuff like that. And I wrote this code. I wrote most of the underlying code. And one day I woke up and I looked at the code and I said, I don't know what I'm doing. I don't know which form valid am I calling? And so I wrote this handy little method, which, just loops through and grabs MRI. It's not hard. And this is the ancestor chain that I got. So that was scary. It is scary. It remains scary. So then what I did is I took my little MRO thing and I checked, OK, let's look up the versions of this class which have form valid as one of the methods, one of the ancestors that has form valid as one of the methods. And in this case, I found that there's 5 of them. And after digging into source code, it wasn't too hard, because this is actually just going to core Django, not my code. I found that I had just one ancestor. So I was relieved. I was happy. I felt in a good spot. But the thing is I was lucky. And you can dig yourself a hole with this. This isn't just with Django. This is with any heavy class-based, multiple inheritance, crazy thing. The question is did the few lines of code that I didn't have to write because of my mix-in pattern, was that worth the anxiety of not knowing for certain how my ancestor chain worked? So there's several mitigations. There's a number of them that I can think of. One is you can always hope that you leave the project and then the person who follows you isn't an axe murderer, isn't going to come and kill you. And that's unfortunately the path that I took there. I can convert it to a functional view, right? So the people who are advocates for functional views in Django will say, oh, function-based programming is the way. You never have spaghetti code. And decorators, you should have just wrapped it up in decorators. No, it doesn't. That's not necessarily the answer. Of course, I could learn better programming patterns, or I could just call explicitly the update view.form valid pattern, bypassing super because I don't know, and I need to be explicit. And one of the things that we like to focus on in Python is explicit behaviors. So yeah, this is the sort of stuff I wake up in the morning and I'm thinking about. So I have this to do that I want to do at some point is write a magical introspector for Python that works with all kinds of things where I can kind of think at it to give me the data back, and it'll give me exactly what I want to know. I know there's a module called Jedi, I think it is, that someone just recommended to me, and I keep meaning to look at it. So, but yeah, that's something I hope to work into. But anyway, let's move on to controversy. Since I've picked on Django, I get to pick on other stuff, right? But I'm nice. I try to be nice. Okay, I'm quoting from the Zen of Python, which is special cases aren't special enough to break the rules, although practicality beats purity. And everybody knows the Zen of Python, right? Raise your hand if you know the Zen of Python. Okay. For those of you who the one or two people who aren't, we like to argue framework and design decisions over the Zen of Python, and it's kind of like our Bible, so everybody interprets things a little bit differently. So this is what I'm going to talk about, is lines 8 and 9. I think I'm going to bring up Web2Py. Remember, I've already dissed on Django, so I get to complain about Web2Py now. But not hard. I'm nice. So Web2Py has implicit behaviors, and it has its own namespace pattern. And for example, actually I want to go into something really quick. At the top, there's some UTF-8 stuff. As an American who's now been in Europe for over 2 months now, I get it now. Okay, yeah. Well, I thought I have to explain myself, but I don't. Oh, that was really nice. Okay, so this code was written by Massimo himself, and I've actually talked a little bit about this stuff with Massimo. So, like I said, this is a little bit friendly. The thing is, when you look at this code, this is from a project that he was building an e-voting system for the Python Software Foundation. Him and David Mertz worked on improving the voting in of board members and other decisions in the Python Software Foundation. I'm guessing with the new Python Software Foundation design that Van Limburg talked about yesterday morning, you'll all get to touch on this code. And this code, if it is still this version, and if it's still here on GitHub, is written by Massimo. So this isn't just like crazy stuff I wrote. This is by the framework's founder. And here, there's this response object in the Python code. And there's no import for it. It's just magically there, like a built-in. And this is what I usually call, or I normally call, namespace pollution. I don't know if that is the technically correct term. I'll probably get corrected on it later, but I like to call it namespace pollution. You've got your foreign objects in my namespace. It's wrong. And when you see stuff like this, it makes you wonder what can you expect in any location in the software. You have no idea. And so my contention is that Web2Py breaks 3 rules in the XenoPython. The explicit rule, in the name of ambiguity, refuse the temptation to guess, and the namespace thing that I really, really like about Python. And yeah, and it's there. Those are the lines. So with this, this is the controversy. Special cases aren't special enough to break the rules, right? Well, Web2Py will contend that they've got a good reason for this, that they're breaking, that they know what the rules are, and that they're breaking them on purpose. So this is how I interpret things with Web2Py. By having the request object and a number of common HTML objects that you need in views and various other views and models and other modules, it's easier for beginners to learn. And also the namespace is easy to learn. It is obvious. Requests. If you're dealing with an HTTP web system, you're dealing with requests and responses and HTML objects. And lastly, and after typing in from django.contrib.auth import get user model a couple thousand times already, I can tell you their avoidance of boilerplate makes me wonder if, well, actually no, it doesn't, but it's a good argument that maybe we're typing a little bit too much boilerplate. So with Web2Py, it's arguing for practicality in some very specific places, and there are always people who are going to have issues with Web2Py over this. And honestly, I've been one of those. I guess I've relaxed a little bit about it, actually a lot about it. And the thing is, it's okay. I mean, magic is, there are people from other languages who will look at Python and say, oh, why are you dealing with white spaces instead of curly brackets? It's not, how can you tell where things start? I don't like that pattern. Or iterators. Maybe someone has a problem with the fact that I can do for x in y, where y is some iterable object. Maybe people have an issue with that. But the thing is yeah, a little bit of magic goes a long way. That's art by Audrey. And case in point, yeah, I love the glitter. Just to let you know, yeah, there's Flask, and it's requests object. If you doubt me, go to Flask requests. If you are in a Flask function, a view, and you have import requests, and then you can just start playing with the request object in the view itself. Armin made that as a conscious decision. I really respect Armin. He's a really smart guy. And he added a little bit of magic, and the result is a really awesome tool. People love Flask. People are religiously fanatic about Flask. And I think part of it is just this little bit of magic really makes things better. By the way, with the animation, real quick side note, I'm not Paul Hildebrandt. I don't work for Disney, but so I'm trying to follow in his footsteps, so I've got some animation sprinkled in. Okay, next part of the talk, exceptions. This is where we get into evil stuff, okay? Evil stuff. In fact, it's so evil, I'm bringing out the Comic Sans font. Silent exceptions. Silent exceptions are really awful. And a few years ago, I had a project where I did something like this, and I know there's a very high-profile developer who I was working with for a little while. He's become very high-profile, and I was working with him a few years ago, and he wanted to use silent exceptions in a number of places, and I told him, you can't use it. Silent exceptions are the devil. And so he's like, well, I disagree. I'm just like, well, I'm in charge of the project, so my way or the highway. And so I happened to notice him in IRC a few minutes later asking, hey, is there anything wrong with this code? And the response to him was like, don't do that. Silent exceptions are the devil. So anyway, however, I did them recently, about a year and a half, I guess about a year ago, I was still using them in one particular place. So in Python, this is XenoPython, the statement about it. You know, we shouldn't ever have silent exceptions unless we explicitly silence them. And I'm going to bring up a project that I maintain with Audrey called Django Packages. And what it is, it's an adjunct to the Python package index, but for Django. And it's a big catalog and index of all the Django packages that people have entered. And it hits GitHub, Bitbucket, the Python package index. And it gives you metadata so you can figure out what you want to work with. And sometimes things go wrong. You can see the list. There's APIs go down, they change. The internet sometimes flakes out, or just sometimes people move a repo, or they delete a repo, or things get taken off the Python package index. So sometimes things break and fail, so we have to analyze it. And this is what I used to do. This is what was there for a while. And you can probably see what's wrong. And here, I'll go into explicitly what I was doing wrong. So here, I don't know, when I was getting an error and then I checked the log, I would not know what the error type was. I would not be able to see a stack trace. I just get the error message. Whoops. There we go. So I just get the error message. Name B is not defined. What I really wanted was something like this. If I'm in my theoretical Python shell, I want something where if B is undefined, I get a traceback, the full traceback, and I want to get that logged. I get the error type, and I also get the error message. I want all this information. And my code, and I've been doing Python professionally since 2006, was in gross violation of the Zen of Python. And I'm sure the Python Software Foundation was going to come down on me hard. I don't think they can do that yet for your bad code, but maybe next year. So this is the process that I used to get what I wanted. And this part right here, I'm just motioning because I don't have a nice flag. That's a print. I mean, since it's a print statement, it's not colorized. But that's a traceback. And that's my error message, the little text message I was capturing before, and that's error type. And basically, this would be using a custom error handler. And the implementation was, I basically wrote this nice little custom exception. It's easy in Python. And with a nice message, a nice full traceback. Oops, let me go back one. There we go. So the nice full traceback was thanks to Richard Jones, who's off in PyCon Australia. Hey, Richard. And he gave me or maybe it was, it was Richard Jones. And now I have all errors caught, and I loop forward. Once I do that, I log it and I loop forward. I continue. So I capture the error, and then I explicitly silence it and continue going, which is, again, now I was in compliance with the Zen of Python. And I got to, I took off that issue, and I took off the fact that I'd silenced things. So that's kind of one of the things when we're working with Python, the easy route, especially with exceptions, and this is speaking to those of us who are, still getting up to speed on it. The easy thing is to do accept exception as E, and just try not to do it. Custom exceptions are really easy to learn. Use them, abuse them. It's better to abuse custom exceptions than it is not to use them at all. Okay. All right, next up, I'm going to get really scary. I'm going to, I don't know if this is picking on Guido. And so nice little side note, I can't talk to Guido Van Rossum. The few times I talk to him, I just kind of gush like the fanboy I am. And it's been like that forever. I'm going to talk about decorators. I love decorators. Decorators are awesome. And if you look on the right, this is how it used to be done in Python, where you'd wrap a function in another function. And now we have this lovely syntax on the left. And when you use decorators, it's awesome. I feel at peace when I see decorators in my code. When I have a good implementation of decorators, I am in nirvana. It is awesome. And but there's nothing's ever perfect. Yeah, that's the pinch. It's and the thing is Nick Mathewson, some guy who I wish someday I want to shake his hand. Yeah, he wrote this years ago, and they used to capture these funny statements. It's great to look up these quotes. I should have made a shorter link. If you can't read this, it's you try to shoot yourself in the foot to realize there's no need since Guido thoughtfully shot you in the foot years ago. So the simplicity we have with decorators doesn't match the what the implementation requires. And this is a decorator template. Matthew Harrison, he's a good friend of mine, and he kind of guided me through really getting it down a few years ago. The way it works with decorators is when the decorator function returns a wrapper, and the wrapper function does things before and after the function is called here, and the result is returned when the wrapper is done. This is the Dutch way. There should be only one, and preferably only one obvious way to do it, although that way may not be obvious at first unless you're Dutch. So let's actually do a decorator implementation. We're going to assume that making things all caps is a memory and time-intensive function. Just bear with me. I'm going to explain this because it's really easy if you're Guido or Dutch. So you've got your data store. If this were web scale or an enterprise application or in the real world, it would be using Redis or Memcached. And there's our return function. We return the value if the arguments that are passed into the function that we're calling, if they're in the cache, then we return what's in the cache as the value, because the cache is just a dictionary. And here we set the cache. We basically call the original function of all caps that is being called right here, but from the args. And we also set it to the cache at the same time. We return the value. So that's what we do. And the wonderful thing about this function is we get much, much faster capitalization or uppercasing of our strings. Because that's where your bottlenecks are going to be. OK, so that actually isn't too hard. Yeah, this is where it gets hard. And I've had people who, after I give this talk, when I've practiced this talk a couple times, they'll say, well, if you just explain it as X, Y, and Z, it's really, really easy. And it just goes over my head and over the heads of the other people around them. This is hard to get this across to people. And that's because we're doing, there's recursion. And I don't know, is this technically recursion? So no, but it feels like recursion. Can we just say it's recursion? OK, so we have a multiplier decorator. In this case, we want to decorate the all caps function with something where we can multiply it. So if I have a string that is, for example, EuroPython, I want it in all caps, and I want to say it 5 times, I can use this great multiplier function, which this is a feature that the big client wants. So here, I've got my multiplier function, or the multiplier decorator sets the state for the multiplier function. Here we go. I'm going to try and do this in one breath. OK, let's go. Ready? I can't do it in one breath. Yeah, so we've set the state. And then when the decorator function is called, the decorator function returns the wrapper function. And then the result is returned when the wrapper is done. And the wrapper function does the multiplication. And I have no idea what I'm supposed to feature there. And this is something trivially simple. Imagine if we had complex business logic attached. Okay, it's a pain point. And the thing is, I'm not done either. There's what is it? There's I've lost the documentation. Right? I mean, if you know decorators, you know I've lost the the doc string, I guess. And there's also what about, I guess, method decorators, class decorators, all that good stuff. Yeah, if you're you have to use func tools if you're writing decorators a lot. So, OK, I'm done. I'm not going to show any more decorator code because that part's hard. Yeah, so this stuff's hard. Yeah, and I'm not doing the class decorators. The thing is. Yeah, you feel this great zen when you use decorators, and unless you've got your nose into them a lot of the time, or you're David Beasley or Andrew Dawkey or Alex Gaynor or Armin Ranischer, it's not easy. It takes a little bit of mental bandwidth to get it. And it took me a while to understand this, because it's not just that they're hard. It's like, why are they in Python? Isn't everything in Python supposed to be easy and obvious? And the thing is decorators are hard to explain. And it suddenly hit one day. There might be a very good reason why this is hard. Earlier on in the talk, I talked about how class-based views can get you into trouble. What's even worse is, it is worse, or just as bad, is when you have too many nested decorators. Has anybody dealt with this one? Okay. Yeah, I see a few nods in the audience. So yeah, I've dealt with it. Just like fancy, crazy object inheritance patterns, take it easy on the decorators. Think about what you're doing or what you're giving to people, or what you're doing to yourself 6 months down the road when you have to go back to your code. The other thing you can do, of course, is use a decorator library, which is on PyPy. You can just look up, the Python package index /decorator, and it's really useful. It lets you flatten your decorators, and it makes all of this really trivial, which makes writing spaghetti code that much easier. So go for it. Okay, let's go on to the next section. This is avoiding technical debt. So these are a couple statements I like to think about periodically, which is, just getting things done at a reasonable pace. This is another 2 lines from the Zen of Python. And there are things on any project that take time. And these are them: tests and documentation. If you have to hit that critical deadline, invariably, unless the only way you can test the results of your code is through formal tests, tests go and documentation goes. And you can skip them, and there's a few risks. See, that's my Wreck-It Ralph stomping on things animation. So there's multiple coding standards, there's broken code, upgrading dependencies. This is a great one that I keep on running into on projects. Not mine, maybe a couple mine, and then of course this one, which is the really nasty one. This is where I always think the bus factor kills you, is the installation deployment of a project. So if you are not sure about what you should cut with tests, always at least make sure the test harness runs, because if it stops running now, there's a good chance no one will ever get it working again until you do version 2 or version 3, the next version. Also for documentation, installation deployment. This is where the bus factor stuff kills you. The other things are great to have, but just make sure you write that down. It's not hard. And then for test patterns, what I like to do is, instead of using the shell when I know I don't have time to write tests, that's where instead of using the shell, or the REPL, excuse me, then what I use is I use tests. I use unit tests instead of the shell to memorize things and explore things. Reject any code that drops coverage, and of course use coverage.py. So this is kind of for the easy wins in projects. I know that yesterday Martin talked about that kind of stuff. So let's get a little bit technical again, and we're going to go to part 2 of this section, which is namespaces. I mentioned I like namespaces. Who here likes namespaces? Okay, not everybody. Okay, so the thing is with namespaces, and by the way, this is being sarcastic now. I'm dipping into deep sarcasm. Import star makes you develop faster, okay? So if you need the regular expression library, just do from regex import star. Same thing works for the OS module. Twisted, let's just import all of it. Django forms. This is awesome. And there are video tutorials online which will teach you this great trick. And the reason why, there's some really good reasons why this is so powerful. And that's that it's useful. It imports everything at once. You don't have to memorize a library. You just kind of have everything in the namespace. It's wonderful. Did I mention I was being sarcastic? So what I've done is I've written this nice little function called compare, which compares two modules, two packages against each other to see if there's any collisions that might be happening. So that way, if I do from re imports, regex import star, or from os import star, if there's going to be any problems. And here I'm executing an action. And if I compare the OS module and the RE module from the standard library, I get two collisions on the sys object and the error object, or function, or whatever those things are. I don't know. I haven't even looked in it. If I compare re.sys versus os.sys, it's true. So odds are I'm not going to collide there. I'm not going to have a problem. However, on error, I've got problems. Okay? I have no idea what those problems are, but I bet someone's been hurt by that. So yeah, import star can get you into a bit of trouble. And it can kill your Python. It can break the built-ins. So I wrote this other little function called compare built-ins, which takes, let's say, the regex module or the regex library or the OS library, and it checks to see if we're going to collide with any of the Python built-ins. And let's see what happens if I compare regex against the built-ins. And here, I overwrite the compile function. And odds are it's not going to kill you. I mean, at least for the work I've done, I don't think it's going to hurt me. There's other people may have different use cases. If I import the OS module, well, I replace the open function. Yeah, this is a nasty one. This will kill everything. This will drive you batty. And so, yeah. What?
Just use file.
Just use file. Yes, you could just use file. But I use open. Tell you what, how about you? No, I'm not going to get mean on you. Can you say that to every Python developer on the planet? Okay, so yeah, this is the thing. This is the built-in function. The open built-in function is the doc string, and it returns a file object and accepts at minimum one mandatory argument. The OS module's version of open, it takes two arguments. So yeah, it's going to break all the things. So if you're a beginner in Python, my pro tip to you, the tip that you should do is if you see a tutorial that has import star in it, back away. If you think you really need this tutorial, contact someone you respect in the Python community. I do this all the time. Not over the import star issue. I know this one now, but I do it for other things. Contact them and say, hey, is this? What do you think of this tutorial? Make sure you get that vetted for you. So my contention is import star is not for beginners. However, there are libraries that use it a lot, and they use it internally as part of the internal API. Don't copy the internal API. It's for people who really know Python. So, all right. So I guess I need to close the talk. This person right here. This is the person I try to stay at. I always want to be thinking about Python. I don't ever want to consider myself an expert. And that's really hard to say in front of a whole bunch of people who've come to hear you speak. But I'm not the only person who does this. Armin Ronischer let us know yesterday, to stay out of your comfort zone, find stuff that's hard and challenging, and grow, get better. Like, for example, these are things I want to learn. I don't know. I get asked C questions. I don't know the answers to them, but that's not why I want to learn it. I just want to learn it because I want to grow. And if I continue to learn and get better, then I get to be that person. So, yeah, that's it. That's my talk. Stay frosty. Think about Python and other things. I want to thank all these people. A few more. And I've got one more thing. This is what I do at every talk. I need to turn this off or it'll be really loud. Hello? Okay.
So, any question? Down there, very far away.
Can you hear me? Okay, I got it turned on correctly.
I'm sure Fabio will forward.
I thought that you going to somebody else. Anyway, thanks for the talk, first of all. But you said that we should not use super, like never. But what if you would have to write your own mixed-in class? What would you use in that
So
such
what
a case?
I don't believe I actually said don't use super. I said be careful. Know what you're getting into. Maybe I should have been a little bit more explicit instead of implicit.
Yeah, sure, but it's worth to mention. But super is not bad. I mean,
No, it's not at all.
Okay, so.
Yeah. So let me restate a little bit. Super is awesome. It is really powerful. It is a great tool, just like Python. But you know, I can crash my laptop using Python. I can do it right now. All I have to do is do for x in range and just hit 1 and start doing zeros for a minute. I did that at PyCon Philippines last year in front of 30 students because I thought I was doing a generator expression instead of list comprehension. That was an awesome moment of my life. So yeah, it's a tool, and like any tool, it depends on how you use it. So if I give this talk again, I will clear that one up. Thank you. Any other questions?
More questions? Oh, down there.
In the decorator function that you showed us, you set the cache to an empty dictionary, and then you change it. Isn't like the most horrible thing that you can do in a decorator is to change the state?
Why, yes, it is. That's why.
Just wanted to clear out.
Yeah, okay. Yeah, that's an excellent point. Yeah, the cache should have been outside, or it should have been hitting an external object. When I took that code from a cache function that I was using that was hitting an outside data store, and thank you. I'm schooled. See, I admit what I don't know.
Okay, some more questions.
So you suggested that having your user-defined exception type was better than no exception type. Where's the balance between user-defined type exceptions versus using one of Python's built-ins, like value error or type error?
Okay, so you want me to compare, or you want me to tell you when is the moment to use a custom exception or a system design, or Python-defined exception?
Yes.
Okay. Before I answer this, I want to introduce Andrew Dalkey, who on 2 days after Audrey, or the second day that I knew Audrey, he gave us a tango lesson. We consider that our first date. So thank you. All right, so he's got an excellent question. With Python, there's a whole wonderful treasure of built-in exceptions, and it behooves you to look at them and learn them and memorize them. But when there's one that doesn't apply, and you kind of have to use your own judgment, that's the moment at which you would define your own exception. And in a lot of cases, I tend to use just a plain vanilla exception base class. But other people I've seen, if I have something that's kind of touching on attributes, but isn't quite I guess what is an attribute error, I'm in front of thousands of people and I can't remember this, so please forgive me. In that case, I've seen them subclass that. So I think there's a little bit of an art. It's just like writing tests. When you first write your own custom exceptions, when you go back several months later, you look and say, what was I thinking? And I think it's kind of that. It's a learning experience. Does that answer your question? Okay, so he said, yes, I win. Woohoo. So he's really smart. So, okay.
Anybody else?
There's one right there.
around the room in an incredible fashion.
Exterior needs a small room. So thank you for the presentation. And about this print E thing that you have done at the beginning, I've seen this done by a lot of beginning Python programmers.
You mean for the super, trying to figure out the ancestor?
No, this printing the exception using print. And a lot of them went on, wait, why doesn't this print a nice traceback and the name of the exception and everything?
Okay.
I kind of couldn't answer them because you would think that it would do that.
Let's see. You can make it do it. What I didn't tell you in the talk is where I'm using print, and that's just to run this little script so that way I know that I'm getting exactly the response I want before I display it to everybody here. So I use print, so it'd be nice in the REPL. Print is actually supposed to be log. I'm logging this. And what this is doing is this will be logging. I'd be using, the logging library, or either in standard library or something else to register those issues, save them to a log file, or email them out, whatever I do. So,
of course, but the question is, why don't the default Python exceptions do that?
Oh, are you answering that, or?
Yeah, there's a standard. Maybe the microphone helps. They can't record it.
Yeah.
There's the traceback module in the standard library, and you can call traceback with the exception, and it gets a configurable traceback with a number of lines. And there's a traceback2 module somewhere in the internet where you even can print the local variables. So it's in the standard library.
He's saying, why isn't it the default? And I think Andrew, my Tango mentor, has an answer.
Well, actually, in Python 1 and Python 2, the stack trace and the exception were different variables. So you originally had to go to syst last exec and syst.last exec value, I believe. And so entirely different variables. It wasn't until Python 3 that they were actually combined together. And so I guess Python 3 is keeping the Python 2 heritage of just showing you the type and not the entire traceback.
Yeah, so, and it sounds to me that, I guess with the logging library, there's an original implementation. If they change it, it'll break too many things. And this is why sometimes it's good for things not to get into standard library, so that way they can increase what functionality or change the functionality. And this is why I know some people have refused to let their packages get into core.
Anybody else? Is there somebody?
No one else?
Can't see. No? Okay. So, thank you very much again.